Hello everyone, welcome to the class on basics of electrical and electronics engineering. And in this video we are going to deal with module 3, that is the behavior of AC in different circuits. And this particular video will be covering the course outcome 2, that is to analyze AC circuits with R, L and C loads. And firstly, we are going to look at the behavior of AC circuit when you are placing a resistive circuit, that is a purely resistive circuit. So to a resistive circuit, I am going to apply an input voltage Vm sin omega t, and the voltage across the resistor is going to be marked as VR, and the current through the resistor is marked as IR. So the voltage across the resistor will also be Vm sin omega t. As you can see, the source is connected directly to the resistance. So VR and V are one and the same. And the current across the resistor, you know that the voltage and current are in phase. And because of that, I'm going to write the general equation. I'm not going to go to the details. IR can be written as Im sin omega t. So if I'm drawing the waveform of the voltage and current, I'm getting a sine wave of the voltage. Please excuse my drawing. And I'm going to get a figure for the current like this. I'm going to get a graph for the current like this, that is IR. So you have the voltage waveform VR and you are having the current waveform IR. Okay, so from these waveforms you can see that, see over here it is sine omega t, and sine omega t there is no phase difference. So we are going to look at a few parameters, that is when you are applying an AC waveform, what is going to happen to certain parameters. And the first parameter I am going to see is the phase difference, or phi. So phi is the phase difference between the voltage and the current. So look at the phase angle of voltage. Voltage is 0 and the phase angle of current is also 0. So hence over here the phase difference is 0. And the next parameter I am going to check is the power factor. And the equation for power factor is cos phi. And you already know that you have got over here phi is 0. So cos 0 will give you 1. So in a purely resistive circuit, your power factor is 1. The next parameter I am going to check out is the instantaneous power. Instantaneous power. And I am going to represent this instantaneous power with small p, and small p will be the product of V and I. V and I. So in this case it is VR and IR. So I am going to get Vm sin omega t. I am just going to substitute the equation Vm sin omega t into Im sin omega t. So you will get it as Vm Im sin square omega t. So you've got the phase difference, you've got the power factor, you've got the instantaneous power, and the next parameter I'm going to check out is the average power. So the average power, I'm just going to represent it as P average. The average power is given as the average value of the instantaneous power. Okay, so the average power is the average value of the instantaneous power. So the instantaneous power, you already have an equation, and you already know how to find out the average value of a sign. So if you want to find out the average value, if you are taking a general signal, it will be 1 by t integral 0 to t. We had taken a general signal, that is v of t dt. This was our general equation, right? So instead of V, I am having P over here, right? Instead of voltage, I am having a power. It's a general equation. And the time period. Okay, so here you can see your power is actually, this is your equation for power. So you are having Vm Im sine square. So again it's a sine term. You can see over here it is a sine term. So if it is a sine term, we have seen that if you are taking the average value, it can be 0. It will be 0. So because of that, I am going to take only the half cycle. You know that the time period for a sine wave is 2 pi. So if I am taking the 2 pi, it can lead to the 0 average value. So what I am going to do is that I am just going to take the half cycle, okay, since it's a sine square term. So I am going to take the half cycle. So that will be 1 by pi integral 0 to pi p dt. Okay. So this is going to be my equation for the average power, and then I'm just going to make the substitutions. 1 by pi integral 0 to pi Vm Im sine square. So here it's omega t, so that's why I'm going to integrate it with respect to omega t, since my axis is omega t. I'm going to integrate it with respect to omega t, sine square omega t d omega t. So I'm just going to take Vm and Im outside, so you will get 1 by pi integral 0 to pi, and here I'm just going to write down Vm Im sine square omega t d omega t. Okay, so the remaining portion is a simple integration. So I'll just go to the next page. So you have P average. I'll just rewrite the equation. Vm Im by pi integral 0 to pi sine square omega t d omega t. So you are already familiar with the trigonometric equations, that is you have a value sine square omega t, and you already know that sine square omega t can be written as 1 minus cos 2 omega t divided by 2. Okay, since integration of sine square is difficult. So I am just going to make the substitution Vm Im by pi integral 0 to pi 1 by 2 minus cos 2 omega t by 2 d omega t. So you can carry out the integration. So I'm just going to do the integration over here. Vm Im by 2. So the integral of 1 by 2 will be omega t by 2 minus cos 2 omega t. The integral of cos 2 omega t will be sin 2 omega t. So you have sin 2 omega t divided by 2 into, then you have 2 again over here. So it will be 2 into 2, 4 from 0 to 5. So I'm just going to do the integration. Oh, sorry, it is over here Vm Im by pi. Right. So you can just apply the upper limit and lower limit. So you will get Vm Im by pi. So you have the upper limit is pi by 2 minus sine 2 pi by 4. Just write it more clearly. Right. I'm sorry. So 2 pi by 4 minus 0 by 2 plus sine 0 by 4. So what you are going to get over here? So again you know that sine 2 pi is 0, sine 0 is 0, then here you have a 0. So your remaining you will be getting Vm Im by pi into pi by 2. So pi and pi gets cancelled. You are left with Vm Im by 2. And I'm just going to rewrite this Vm by root 2 into Im by root 2. And I can write this Vm by root 2, I can replace it with Vrms, and Im by root 2, I can replace it with Irms. So finally you are getting the average power is equal to Vrms into Irms. So this is your average power. So we have got the phi, phase difference is 0, power factor is 1, instantaneous power, you just multiply them both, and the average power you have got it as Vrms into Irms. So the next parameter is the next three parameters that you have to study are the simple ones. You are already familiar with the apparent power, active power and reactive power. Apparent power is represented by S and it is given by Vrms into Irms. So you can see over here our S and the P average is the same. Then you have active power capital P is equal to Vrms, Irms, cos phi. So here you all know phi, cos phi is 1, so you are getting it as Vrms into Irms. So again you can see over here your P average and P is also the same. Then finally you are having the reactive power. Reactive power is given by Vrms, Irms, sin phi. So phi, the value of phi is 0. So you have sin 0 is 0. So you have the reactive power is 0. So these are the certain parameters that you have to study as a common way in when you are applying different circuits. So this is the case of a resistive circuit. Again, it's just a recap. Phi is 0 for a resistive circuit. Power factor is 1. Instantaneous power, you just simply multiply them 2. The average power you will on integrating the instantaneous power, you will get it as Vrms, Irms. Then apparent power is V into I. The active power is Vi cos phi. For all the voltage and current you give RMS, and cos phi is 1 in the case of resistive circuits. Q is Vrms, Irms sin phi again phi is 0, so you will get it as 0. So the next case you can look at what happens when you are applying an inductor. So when you are applying an inductor, again you are having something like this. Okay, it's a purely inductive circuit. Again you are applying the voltage Vm sin omega t, and you are applying a voltage inductor, and the voltage is VL, the current is IN. Okay, so again the voltage VL is Vm sin omega t. And I'm not going into much of the technical details. The current through an inductor, you can write it as, since it's a purely inductive circuit, you can write it as Im sin omega t minus pi by 2. In my previous lectures, I have already mentioned that the current in an inductor, in a purely inductive circuit, it is always lagging by pi by 2 degrees. So I'm just writing that. We are not going much into the derivation. You can just refer the notes for the derivation on this equation, but I'm not going to focus much on that. It's not it's something that it's a general equation. Okay, so the current through the inductor, a purely inductive circuit, is given as Im sin omega t minus pi by 2. And we have to go through all the different values we had mentioned in the resistive circuit, that is phi, power factor, instantaneous power, average power, then S, P and Q. So again, you just draw the circuit over here. You can see this is your voltage across the inductor, and the current through the inductor, you can see it is going to lag by 90 degrees. So this is going to be your current. So this is IL, it is lagging by 90 degrees. So obviously what will be phi? Phi will be equal to pi by 2. And you can see it will be minus pi by 2. The minus is denoting the lagging nature of the current. Okay, so it is minus pi by 2. And if you are taking cos phi, you have, or sorry, not cos phi, if you are taking the power factor, I'm just going to write a short form PF. You can see cos phi, that is cos pi by 2. Pi by 2 is equivalent to 90. That will give you 0. So in the case of a purely inductive circuit, your power factor is 0. And if you are taking the instantaneous power, that is small p, again it is VL into IL. So you have Vm sin omega t into Im sin omega t minus pi by 2. And you have already studied in your theory sin 90 minus theta, you can write it as minus cos theta. Yeah, so this is again a trigonometric relation that you must be aware of. So I'm just going to rewrite sin omega t minus theta. That will be Vm sin omega t Im minus cos omega t. So you will get it as minus Vm Im sin omega t cos omega t. So the next parameter I need to find is the average power. So again, as we had mentioned, you can see over here there are terms sine and cos, and because of that, again we are, while carrying out the finding out the average value, you can take it as 1 by pi. You're going to take only a half cycle because it is depending on sine and cos. So I'm just going to take a half cycle. You will get it as 1 by pi integral 0 to pi minus Vm Im cos omega t sin omega t. So again, I'm just going to take minus Vm Im outside. So you have minus Vm Im by pi. And instead of sin theta cos theta, again you might be familiar with the trigonometric relationships. That is sin 2 theta is equal to 2 sin theta cos theta. So from this you can rewrite the integral 0 to pi. You can rewrite it as 1 by 2. Right? You can rewrite it as sin 2 omega t divided by 2 d omega t. Okay. Then you can just simply carry out the particular integration. You will get it as minus Vm Im by 2, and integral of sin omega t is cos, here it is 2 pi. So I'm just taking this 2 outside, cos 2 omega t divided by 2 from 0 to pi. You can apply the upper and lower limits. So it is minus Vm Im by 2, Vm Im by 2 pi, and you apply the upper limit and lower limit. So you are going to get cos 2 pi minus cos 0 divided by 2. And finally you are going to get it as 1 minus 1, and you will get cos 2 pi is going to be 1, cos 0 is going to be 1, and you will be getting the average power as 0. So again, you just recollect what we have done over here for an inductive circuit. The phase difference is minus pi by 2. The minus is simply indicating the lagging nature of the current, and then you are having the power factor cos 90, that is 0. Then you are having the instantaneous power. You just multiply these two. Instead of sin omega t minus pi by 2, you have written it as minus cos pi by cos omega t. And you take the average value. You have found out the average power is 0. And finally, you can just find out what will be S. So S is simply Vrms into Irms. So that's the same for all the circuits. Then you can find out the active power. So the active power will be Vrms, Irms into cos phi. So you already know that cos phi is 0. So your active power is going to be 0 in this case. Then you have the reactive power Q is Vrms, Irms, sin phi, and sin phi is 1, so Q is equal to Vrms, Irms. So for the university questions, they may ask for 4 marks to derive that the average power in a purely inductive circuit is 0. That is a commonly asked question. And finally, you are having capacitive circuits. So I'll just briefly say what capacitive circuits is about, and you can try it out on your own. So in the case of capacitive circuits, again, I'm having a circuit over here. I'm applying it to a capacitor. So you are having a capacitance C and the voltage across the capacitance VC, the current through the capacitor IC, and then you are going to apply a voltage V is equal to Vm sin omega t. So the voltage across the capacitance is Vm sin omega t, and the current flowing through the capacitance. Okay, so again, I'm not going to go much into the depth of this particular detail. The general equation for the current through the capacitor is Im sin omega t plus pi by 2 or plus 90. So you can see that in the case of an inductor, it was sin omega t minus pi by 2, and in the case of a capacitor, it is sin omega t plus pi by 2. So all the values in the case of an inductor and capacitor are going to be the same, except over here, instead of negative, you are going to get it as positive. Okay, so you try out finding all these parameters on your own. So please watch the video completely and complete your notes. Okay, so thank you everyone. I hope the video was useful.